in your other pages, I can recycle them over here. I have on this desk over here, I've got a pile of them. Okay, and I can print the attendance on the back of them. Yep. Okay. So my goal is to get through all these examples here with you. You're welcome. Just right there on that. Is there a pile of them there? Okay. Okay, this is a lesson we did last year. Okay, so there is a part of it where we did the proof of the thing last year. I'm not going to redo that proof, okay? Because it was kind of a pain, all right? And you'll probably whine at me if we do it, okay? The other thing I'm going to send around is you guys expressed interest. It was Jade expressed interest in popcorn sales this week. We can't do popcorn and iced tea. We have to give 20% of our profit to football. So, okay. So we're just going to do popcorn and pom-poms. Okay, so for tomorrow's game, it's only part of a game. Okay, it's only a scrimmage, so and there might not be very many people selling, so we have some potential to make some money. If you can come help, sign up. Okay, the sign-up sheet's going around. Okay. All right. So let's talk about solving this differential. Okay. So this is literally all this is separation of variables. Okay. We call it separation of variables for the AP tests. They haven't quite introduced that vocabulary yet. Instead of y prime, we switch that to dy dx. Okay. How do I get this y to the other side? Multiply. So y dy equals 2x. How do I move the dx? Multiply. All right, and then what are we going to do to both sides? We're going to integrate both sides. Good. Okay. When we integrate y dy, what do we get? Y squared over 2 equals 2x, what? 2 plus c. These guys would cancel. Okay. At the same time, I'm writing the next line here. How do I move this 2 to the other side? We would multiply it to the other side, wouldn't we? Remember how we did that c sub 1 thing last year? Whether or not you do it, the AP graders aren't even going to see something like that, and it doesn't bother me if you just leave it c, but technically we're changing the constant. Probably, and the reason we would do it is because we can distribute that in. So 2x squared, what's 2 times c sub 1? What would we write? 2 times a constant is still a what? Constant, so just write a c. You don't have to undo the squared. I don't know why they don't make us keep going, but that's where they stop it.
Ms. Barr, how did you get rid of the 2 on the y?
Here, I multiplied.
Oh, yeah, because they come the
Yep.
2's on the...
I canceled these 2's, and then I multiplied this one over.
Okay.
Okay? Everybody good? So far, hopefully just like what we did last year. All right. So again, what are we going to change the y prime into? dy dx. All right. I need to move the 3y to the other side. So how do I do that? Multiply 3y dy equals... Okay, and then we've got, instead of writing x, square root of x, I'm going to write x to the 1/2, and then what are we going to put after it? Dx. We're going to integrate both sides. All right, when we integrate 3y, what do we get? Over 2, good. When we integrate x to the 1/2, what do we get? 3/2 divided by 3/2 are multiplied by what? 2/3 plus c, or c sub 1. The c is going to change here in a minute. All right, I don't like those fractions. I want to get rid of all the fractions in one step. So here's my little algebra trick. Okay? What's the greatest common factor? Isn't it 6? I'm sorry, least common denominator. Not greatest common factor. What's the least common denominator? 6. So if I multiply everything, including the c, by 6, I don't change it in any way, and I get rid of the fraction. So 2 goes into 6 how many times? 3 times 3 is 9y squared. 3 goes into 6 how many times? 2. 2 times 2 is 4x to the 3 halves. Plus a constant, right? 6 times a constant is a constant. All right, what am I got to get rid of the 9 in front. It lets me leave the y squared. So how do I get rid of the 9? We're going to divide everything by 9, including the constant, which is still just going to be a constant. So y squared equals 4/9 x to the 3 halves plus c. What's wrong?
Then you just multiply everything times the reciprocal of 3 over 2.
Do you get the same thing?
Yeah.
Yeah, you could do that too. It works. Okay. All right, we good with example 2? No? Okay, I'm waiting. Okay. All right, the only thing you need to write down on this one is this little formula, I think. So this is the growth and decay model right there. Okay, so now we're getting to what the essential question was aimed at. All right, so why this is in this section, okay, and why it's in here with this separation of variables is, last year we talked about it being a differentiable function, and that was the differential. We proved last year that this thing ends up equaling this, okay? I'm not going to go through that proof again, all right? It takes, I don't know, there's room for it there, but I'm not going to go through it, okay? C is the initial value. K is the proportionality constant, and if K is greater than 0, or positive, it's a growth. If it's negative, it's a decay. Remember back to advanced algebra 2, and we had this formula, the PERT formula, the shampoo formula, and that was for interest compounded continuously. It's the identical formula, you guys. We put a K in for the R and a C in for the P, but it's the identical formula, same thing. So this is something you've done before, okay? There actually isn't a whole ton of calculus involved in the rest of this. It's mostly algebra, okay? All right, so this is what we're not going to do. You can cross out the proof. Okay, we're just going to use it. All right, so when we see the rate of change of y is proportional to y, that's when we know we're using this funky formula. All of the rest of these are going to use this formula, CE to the KT. Okay? All right. So it gives us some values here. We got an initial value of 0, 2. We've got a 2, 4. And then they want us to find the value of y when t equals 3. Okay? So I'm going to start with this and plug it in. And you're going to see the same pattern happen over and over. What am I going to put in for the y? 2, because I'm using what's boxed right now. E to the k, what's going in for the time? 0, good. Okay. What's k times 0?
0.
So don't I have CE to the 0 power? What's anything to the 0 power?
1.
So what's C? 2. I'm now going to use that and this information to solve for k. But do you see how when we have a 0, every time we have that 0, it basically gets rid of the E and allows us to solve for C. Okay? A lot of the time it's going to have a 0. Okay? And so when you see the 0, this is the way to do it. We're going to see one in a few minutes that doesn't. Okay? All right. I'm going to put in if I'm going to use this here now, what am I going to put in for the y? 4. What do we put in for the C that we calculated? 2. E, we don't know k. What's my time? 2. Good. All right, I'm going to get rid of this 2 in front. How do I do that? Divide it. What do I get when I divide? 2. E to the 2k. Notice I left some space in there. How do we get rid of the E? Natural log both sides. Good. So natural log of E is gone. You've got the natural log of 2 equals 2k. How do I move the 2? Thanks. How do we move the 2 over, guys? Divide it. So natural log of 2 divided by 2. Okay. Put that in your calculator for me and tell me what the number is. Point something. Three, 4, 6. Okay. Now I'm going to take that. Have I answered the question yet? What is the value of y when t equals 3? No, I still need to answer that. So I'm going to do y equals, what was the c value that we calculated a while ago? 2e. The k value is this 0.346. What's the time that they want me to put in? 3. Now it's a matter of punching the buttons on your calculator. So everybody punch the buttons and see what happens. 5 point what? 47. Do we all agree with that?
Yes.
Okay, I'm wondering if I had a bigger... Oh, I know what happened. We rounded, didn't we? What was after the 346? Was there any more to it? Yeah, we went too early. Okay? So try it again with more decimals. 3, 5, 7, 4. Don't count. Don't stop at 3 decimals in the middle of the problem. It's still 5 point something. What are we getting?
5.656.
Good. Do you see the difference between the two? Had it been the AP test, we would have lost the point. Even though we got all the rest of it right, we would have lost the point right there because our decimal places weren't accurate 3 places. Okay, so do you see why those extra digits are very important to us? You'll get a very different answer if you don't have those extra digits. Okay? All right. The next one is an almost identical method. The problem is phrased differently, so the instructions look different. We're going to do the same thing. Do I have an initial point with a 0? Yeah, and then I've got a value to plug in. All they want this time is the function. I don't have to plug in and solve for a y at the end. Okay? So we're still using y equals ce to the kt. We're going to start with this initial point here. What's going to go in for the y? 4. C, and this is going to solve for c for us. K times, what's going in for the t? 0. K times 0 is what? 0. Anything to the 0 power is 1. So c is, oh, I shouldn't have boxed it, but anyways, we boxed it. All right, now I'm plugging in this information here. So what's going to go in for the y this time? 1/2 equals, what's the c value we calculated? 4e to the k to the times t. What's my t value this time? 5. All right. What are we going to do to move this 4? Divide by 4, okay, or multiply by 1/4. So it's 1/4 times 1/2. 1/8 e to the 5k. All right, how do we undo the e? We're going to natural log both sides. I almost didn't receive space for it there. So the e and the natural log go. We have natural log of 1/8 equals 5k. So we've got natural log of 1/8 divided by 5. So you tell me in the calculator, it will turn out to be a negative answer. Tell me what you're getting in the calculator. 0.415888. Okay, now all they wanted us to find this time was the exponential function. So all we have to do is rewrite it with the c and the k in it. So y equals 4e to the negative 0.145888t. Again, we did almost the identical thing. There was one less step in this one than there was in example 3. All right. The next problem has some information that I didn't write in the problem. I missed it, so we're going to add that in, okay, to make the problem make sense. So before we read it, the missing part is I missed writing the half-life in there. Okay, so the half-life is when y equals 5 at time 24,000. Okay, years probably. Okay, so now let's read the problem. Suppose that 10 grams of plutonium isotope Pu-239 was released into the Chernobyl nuclear accident. How long will it take for the 10 grams to decay to 1 gram? Okay, so and again, they gave us some information about half-life as well. So that's going to help us do some solving. I'm still going to start with this y equals ce to the kt business. All right. They gave me the initial value. I don't have to solve for it this time. So what's my c this time? 10. I need to solve for k. But I have this other information about half-life I'm going to use. So what am I going to put in for the y? 5. Okay. And then e to the k times what's going in for the t? Good.
How do you know that's your initial value?
How do we know this is the initial value? Because it said we started with 10 grams. Okay, and that was an initial. Suppose that 10 grams was released. That's an initial spot to start. And it also says 10 grams decay to 1, so it's kind of the there again. All right, how do I move the 10? Divide, what do we get? 1/2 equals e to the 24,000 k. What do I have to do now? So it's the same boring steps over and over, right? Okay, so natural log of 1/2 equals 24,000 k. It's just the way the question is asked is a little bit different, but it's the same steps once we get going. What do I do with the 24,000? Divide it, 2400. Okay. So once I get that in there, what's my decimal point? It's going to have a bunch of zeros.
-0.000029.
9. Okay. All right. Have I answered the question? I need to know how long it takes 10 to get down to what? 1. So we're going to go ahead. This is going to be the y value. Okay, and I'm going to solve for that t. So the y value I'm plugging in is 1. What's our c that we got at the very beginning? 10. E, the k is this negative 0.00029 t. Okay, how do I move the 10? Divide it. So I could do 1/10, I could do 0.1, your choice. Okay. E to the negative 0.00029 t. How do we undo the e? Natural log of both sides. Good. Equals negative 0.00029 t. And then how do I move the decimal point number there? Divide it. So natural log of 1/10 divided by negative 0.00029. Okay. You tell me, what do we ended up with? They told me last period a different number than I had written down, so I'm curious to see what you guys get. 79. What were my next digits? 399.5. That's what they got last period. My notes are wrong. They gave me 80,000 something last year. They actually gave me 2 different 80,000 somethings. All right, are we good with 5? Okay. The next one kind of does the same thing again, but the setup's different. So they gave me half-life. They did not give me my initial quantity, my C. I'm going to switch this to 1,000, not 100, so switch that typo. Okay. Maybe we'll get to this piece over here. We'll see. All right, so they didn't give me an initial. They gave me a little bit of information. I got to find my C. So here's a trick that we can use with half-life. Okay? So a whole of something is one whole thing, isn't it? What would I write for half of it? 1 over what? 2 is a half of it. E to the K, and I know the years in the half-life is the 1599. So the trick again, one whole something. If they give me half-life, I put the half here and the time for the half-life up in the T. Is that the initial quantity at all? No, I'm trying to still find that initial quantity, but I got to get the K first. So this is a way to get the K with the information that we have presented right now. Okay? Do I really need that 1? No. How do we get rid of the E? Natural log of both sides. So I'm going to kind of natural log it. So we got the natural log of 1/2 equals 1599K. What am I going to do with the 1599 to get it to the other side? Divide it. So natural log of 1/2 divided by 1599. What's that going to equal? 433. Good. Okay. And then we need to we got to find the C still. Okay, so I'm going to go back into this original thing that we had, and I'm going to use this information here. Okay, so what am I going to put in for Y this time? Careful. The 1.5, good, equals, I don't know C, that's what I'm trying to solve. E, the K was this number here, negative 0.00433. What's the time? 1000. All right, do I do a natural log this time? Isn't this just an ugly number? How do I get rid of that ugly number? Right now it's under multiply. How do I get it to the other side? Divide it. So we're going to do 1.5 divided by the ugly number. 1.00 or e to the 0.00433 times 1000. All right, put it in your calculator. Tell me what we get. 2.3139 what? 4. And this was measured in grams. All right, so that's what would fill in this part of the chart. There's another part of the chart. I'm not going to do this part, okay, because I think you could probably figure it out on your own. You're going to do the exact same formula again. You're going to do what this is basically, you do the Y equals the C value that we had, which was this thing, E to the K times this time. And you put it in the calculator and you crank out the number. Okay, we've done that a couple of times. So let's, instead of doing that, let's look at the fruit flies. Okay, so everybody look at the fruit flies. Suppose an experimental population of fruit flies increases according to the law of exponential growth. There were 100 fruit flies after the second day of the experiment and 300 after the fourth day. So do we see how there's some values in there for us to work at? 100 after 2, 300 after time 4. Okay, it wants to know how many flies were in the original population. So essentially we're trying to solve for the C value, right? The initial C value. Okay, so I've got to set up a system of equations in order to solve this. So I'm using my CE to the KT again. I'm going to use this information here. So what is the, hold on a second. Okay, so the total after 2 days is how many? 100. So Y would be 100. CE, I don't know the K, but the time is 2 days. Okay. I'm going to set up another equation using the 300 and the 4. So we're going to have 300 fruit flies, and then the time is going to be 4 days. All right, I have to do some substituting. I'm going to use the substitution method on systems of equations. It's just our system looks really weird. I'm going to solve this one here for C. So how do I get this thing over to the other side? Divide it. Good. So 100 divided by e to the 2k equals C. I'm now going to take this and substitute it in the C over here. So 300 equals, all right, I'm putting in the 100 e to the 2k for the C times e to the 4k from the original problem. All right, what's going to happen with the e to the 2k and the e to the 4k? That's going to cancel. This is going to reduce to what? 2. So we have 300 equals 100 e to the 2k. All right, how do I move the 100? Divide it. 300 divided by 100 is what? 3. So e to the 2k, how do we undo the e? Natural log it. Okay, I almost got the k, but I was looking for the c. So we got to figure that out here in a minute. So let's see. I'm going to divide by, what happened? I lost my 2. Natural log of 3, I got to divide by the 2. So natural log of 3 divided by 2, what are we going to get for the k? A number. Five 549306. Okay, where am I going to plug that in now? Could I plug it into this one? Could I plug it into this one? Could I plug it into this one? I'd probably go into this third one because it's already solved for C, and what we were looking for was the C value. E to the 2 times the 0.549306. All right, push the buttons on the calculator. Three point what? This? Okay. So go back and answer the question, and let's look at it and make sure that our answer makes sense in the context of the problem. It says approximately how many flies were there in the original population. So in the context of the problem, are we going to have 0.3333 of a fly? No. So we'd probably say there's going to be 33 fruit flies in the original population. Because having 0.333 of a fly is no good. So think about how disgusting that is. And we live next door, we're here next door to the farm, right? The cow farm. And on the first day they had 33. On the second day they had 100. And by the fourth day they had 300 fruit flies. Okay? Yes, but it's growing exponentially, right? It's doing this thing. It's starting small and getting high really, really fast. All right, so you now have your where you write your homework down. So let's talk notebooks. Okay? So you need to start on week 2, not week 1. So it's in the front. Somehow the bottom of the front part didn't get page numbered. I don't know why. So make sure you're on week 1. Actually, you should be on week 2, right?
Yes.
So for right now, fill in the assignment numbers on week 1. Go 1, 2, 3, 4, 5 down the assignment number column. Okay? And then do 5, 6, 7, 8, 9, 10 down the assignment number column of week 2, and write that one down on the number 9. Okay? And you guys know the drill. Most of you have had me before. In fact, I think you guys had math analysis notebooks 2 years ago. You guys were the first group that got any notebooks at all. Because in math analysis, we've been doing this for 3 years now. In fact, I went over there to look in the pile. It's all of the kids I have 4th period, but I still have some of the math analysis notebooks from 2 years ago that never got handed back. None of yours, I looked. Oh, wait, maybe I might have Greg's, actually. I'll go look again. Most of them were 4th period. Okay. Once you've done that, let's make sure the notebook gets kind of cleaned up here, okay? Okay, we got it written? Okay. So the next thing I want you to do is I want you to go to your notebook. I want you to go to the very front cover. And you should probably do this in pen. If you haven't done it yet, please write your last name followed by your first name and period 5. Okay? And then at the bottom, write Ballard. Okay? And 727 is the room number.